Okay, we have here today a nice integral from the MIT Integration Bee 2025 quarterfinals tiebreaker number 1. We have the integral from minus 2024 to 2026 x 1 plus cosine x minus 1 2025 pi dx. Okay, there's quite a few different scary parts to this. First of all, the bounds. It's nice that they got something around 2025, but we usually like it when it's symmetrical, like if it was positive 2024 or negative 2026. And also the input on the cosine is kind of messy, so I think I want to deal with that part first. There's a lot of different choices in this. I know like 4 ways, but they're all kind of the same thing. We could do a u substitution for all this. I think what I want to do instead, let's just do the u sub for this part right here. I'm going to leave the pi out of it for now. So I'm going to do u equal to x minus 1, 2025. I think that's going to clean it up enough to make this work. Then from here, I think what I'll do is solve for x. So we can rearrange this. I can break this up, add 1 over 2025 on both sides. We have x over 2025 is going to be u plus 1 over 2025. Then if I just multiply in by 2025 on both sides, we isolate our x and we get x equal to 2025 u plus 1. Now I'll go ahead and take a derivative, get the dx value. Derivative here is just going to be 2025 du. So now I'll go ahead and substitute. First, updating the bounds, plug 2026 in here. That's going to become 2025 over 2025, or just 1. Plug in minus 2024, we get minus 2025 over 2025 minus 1. So that's pretty nice. Plugging in for our x value, we're going to have all this stuff here, 2025 u plus 1. Then here, this is going to clean up the cosine part, so it's going to become just cosine u pi. Then for our dx, the constant we'll bring up front, we're going to have du, and then we'll bring the 2025 right here. But with the substitution, that fixes the thing I was worried about originally, because now our bounds are symmetric around 0. It makes me think we can use even and odd functions. The way it's broken up right now, it doesn't quite work. Keep in mind, cosine, this is going to be an even function over here. I think all I need to do to use this is let's just distribute in this first term, distribute it in here, and break it up into 2 integrals. Okay, now from here, what I want to do is let's deal with this second integral. And we'll recognize this here is going to be an even function because cosine's even, the 1 doesn't really matter. So if this is our f of x and it's even, we can use this principle right here. When f of x is an even function and our bounds are symmetric around 0, we can turn the lower bound to 0 and bring a 2 out front. So we'll just do that right here. And next we'll deal with our first integral over here. For this one, we can notice that it's going to be an odd function because this is going to be even. Just a u, that's going to be an odd. If you plug in, what you can do is if you do if this is our f of u over here and you plug in minus u, you're going to have a minus pop out. That's how we know it's odd. So let's just look at our principle of odd functions. Over here, when we have our f of x odd and our bound symmetric around 0, we can just say the whole integral is 0. So what happens is this whole thing is going to be a 0, so we can just kind of wipe all this out and we can deal with a much simpler integral over here. So dealing with this is going to be an easy integral for us to do. Multiply 2 times 2025 and we get 4050 out front. Integrate this, integral of 1, that's just going to be a u. Integral here is going to become plus sine u pi. We're going to have a pi pop out in the denominator, and we just need to evaluate from 0 to 1. But then notice when you evaluate at 0, everything's going to be 0. Sine at 0 is 0. So this goes away. But when you plug in 1, because we've got the pi there, sine of pi, that's going to be 0. So this term goes away, and we're just plugging in a 1 here. So just distribute 1 to this, and for my final solution to this, we just get 40, 50, and that's it. Okay, so there you go. It kind of looks intimidating, like it's going to be difficult, but really with the substitution, it works out pretty quick. Okay, that's it for today. Thanks everyone for watching. Have a good day.